Hello friends, in this video we will see how we can calculate the enthalpy of Vapour mixture by using LabVIEW and MATLAB. So here, to calculate the enthalpy of Vapour mixture, I am taking the system of benzene, toluene and xylene, and here we will try to calculate the enthalpy of these three components mixture. To calculate the enthalpy of each components, we have to know the initial data. So first data we should know what is the normal boiling point of each component. So this is the normal boiling point of each components, and here the boiling points is in Kelvin. Now next value which is required to calculate the enthalpy of each component, this is latent heat of vaporization. So we have to enter each component's value, that is 30781, 33201 and 36844 I am taking. In the continuation of that, we need one more data. This is your critical temperature. So the value of the critical temperature of each component is 562.1, 591.7 and 633.2, and this is also in Kelvin. So now here we need one more numerical control. So this numerical control is nothing but this is the required temperature at which we are going to calculate enthalpy of each component. So here actually I am just changing the size and the color. Okay, so now I'll go back to do more calculation here. So first of all, I'll just change the temperature in Kelvin by adding 273 here. So I'll take plus operator. Here I'll take one constant, and from here whatever the output is coming, that output is come in your Kelvin. So now here, with the help of this temperature as well as there's a critical temperature, we'll first calculate its reduced temperature. So for that I'll take this division operator, and reduced temperature is nothing but temperature divided by its critical temperature. So this is your give you value, and this value is your critical temperature. So I'll just represent by TR. Similarly, I'm taking again this divide operator, and this output I'll connect here, and this is your not, and this is nothing but this is reduced temperature at its normal boiling point. So for that again I'll just divide normal point and its critical temperature here. So now this give you TR naught. So we can see in your front window we have this TR, this TR naught, and again if I'll change just sorry, I'll extend three values, three like that. So now suppose I'll take here the 273 and check what the output is coming. So now you're getting both reduced temperature and the reduced temperature at its boiling point, and the reduced temperature at its given temperature. Okay. Now here, after that, we have to calculate the latent heat of vaporization at given temperature. So for that, we have to use math script formula. So from here I'll just take this math script, and here we have to write the code to calculate the latent heat of vaporization at given temperature. So for that, we know that TR, if greater than or equal greater than 1, then assume TR is equal to 1, and HFG we are taking is 1, else HFG is equal to HFG naught into, inside this bracket, 1 minus TR divided by, inside the bracket, 1 minus TR naught, and the power of 0.38. Okay. So now here we have to give the input value. So this is your TR. We have to give HFG naught, and we have to give TR naught itself, and here the output would be HFG. So now this is the code to calculate the latent heat of vaporization at this given temperature. So we have to execute this code the 3 times, means to calculate the latent heat of vaporization for all the 3 components. So for that, I'm taking this for loop, and here I'll just give how many times we'll execute this loop. So 3 times. So I'll just put in the 3, and now here we'll do the arrangement to pass this TR one by one. So for that, here I am taking this index array, and this, and from here this index array I'll just pass this TR first, then from here we are doing this increment, and I'll just pass here this first bit. Similarly, I'll do for this latent heat of vaporization. So I'll just click here, I'll take one more, and from here, and the third one is TR naught. So again I'll take this TR here, and this TR, again I'll take this index array, okay. Now I'll just connect to this outer loop, and from here I'll take this create indicator. So this indicator, it is nothing but it will give you HFG value, and this HFG is nothing but this is the latent heat of vaporization at given temperature. That this is our HFG. So now again, yeah, this is now HFG, and if I'll click here, then we can see okay. So now we have this HFG. So this is the latent heat of vaporization at each component cell. So but now here we have to calculate the enthalpy of each component. So for that, we know the vapor enthalpy is nothing but liquid enthalpy plus latent heat of vaporization at that temperature. So here we have to calculate liquid enthalpy at that temperature. So for that we have two ways. Either we can write the code again here to calculate the liquid enthalpy, or if you already made the VI, so you can take the VI from there. So I have already made the VI in the last video, so you can take the reference of that video. So I am taking the VI of liquid enthalpy from here. I'll just click this one. So this is the temperature in degrees centigrade. So from here I'll just connect the temperature in degrees centigrade, and this will give you the two output. This is liquid enthalpy. So I'll take from here, so I'll just connect. This is liquid enthalpy, so I'll just denote by HL, and next is your Carrier indicator. So this is a liquid enthalpy, liquid mixture enthalpy actually, right? So now as per the expression, HV is equal to HL plus HFG. So here we have to calculate the vapor enthalpy of each components. So for that I am taking one plus operator. This plus operator, it's connect with this HL and HFG, and this will give you HV, and this HV is nothing but this is your vapor enthalpy at this given temperature. So now here we'll see the data. So this is HV. If I run it, then we'll see this is the value of enthalpy of each component here. So now here we need to calculate the enthalpy of vapor mixture. So here we should know the composition of each components. So for that we need one more vapor composition, and this is I'm taking 0.3, 0.3 and 0.4, and I'll go back again. Yes, this is vapor composition, and here we have to multiply your HV with your vapor composition. So I'll take multiply operator, and then I add each elements. So for that I'm taking this one, and from here you can just take this one, this is vapor mixture enthalpy. So now we can see on your front panel, so you can see here this is the vapor enthalpy, and here actually I'll just change the color so you can easily recognize this one. So here if I'll run it again, then we can see this is the enthalpy of vapor mixture here actually. So this is the way through which we can calculate the enthalpy of vapor mixture by using LabVIEW as well as this MATLAB code here actually. Here now I'll just select all this one and just clean up the space. So simply you'll just select from bottom and click this this one. So now it's your block diagram is in compact form. Is it in this video? If you like it, then please share and subscribe with your friends. Thank you.